So for both the sections, am I audible?
Yes, sir.
Okay, fine. So for both the section we have covered till now in interference, we have covered interference in thin films, and we have seen in both the cases, in case of reflected system and in case of transmitted system, we have derived conditions for destructive and constructive interference, right? And also we have seen interference in wedge shaped films, and we have derived, okay, in both the cases we have derived conditions for constructive and destructive interference. We have seen how the interference pattern will look like and how the locus of the fringes will be there in case of these type of interferences, and both of these cases were the type of division of amplitude, right? Now the third case of this system, this type of interference, is Newton rings. This is also, this Newton rings is also similar to wedge shaped film interference, and we will see how the interference pattern will be observed in this setup called Newton rings, right? So what we have is, we have a optically plane glass plate P, we have a optically plane glass plate P, एक ग्लास प्लेट है, फ्लैट है, and we have a plano convex lens, a plano convex lens which is placed on this glass plate, which is placed on this glass plate. प्लेनो कॉन्वेक्स है, दैट मीन्स एक साइड प्लेन होगा, एक साइड कॉन्वेक्स टाइप का ज्योमेट्री होगा. So it will be something like this, a plano convex lens, right? Let's call this as L2. Now the convex surface of this lens, the convex surface of this lens, this surface is making a contact with the plate at a single point. Let's say that point is C. प्लेनो कॉन्वेक्स है, कॉन्वेक्स सरफेस है, कर्वेचर है, तो कर्वेचर होगा तो लेट कंसीडर दिस प्लेनो कॉन्वेक्स लेंस is touching this glass plate at a point C, and hence because of this geometry, hence it encloses a thin film of air, it encloses a thin film of air in this region. ऊपर ग्लास प्लेट है, ऊपर प्लेनो कॉन्वेक्स लेंस है, नीचे ग्लास प्लेट है, तो इसके बीच में जो एयर बचेगा, इसके बीच में जो स्पेस है, दैट स्पेस इज फिल्ड विद एयर. नाउ इफ यू लुक इनटू दिस ज्योमेट्री, दिस L2CP, this L2CP is nothing, it is actually a curved, I can say it is behaving actually a curved wedge shaped film. एक ग्लास प्लेट लिया P, एक प्लेनो कॉन्वेक्स लेंस उसके ऊपर रखा L2. नाउ दिस L2CP सेक्शन, दिस L2CP सेक्शन विल एंगल्फ एयर. उसके पास हवा होगा और कुछ नहीं होगा. ये सब ग्लास मीडियम है, ये भी ग्लास मीडियम है, ये भी ग्लास मीडियम है. उसके बीच में जो है, जो वर्टिकल लाइंस, दिस वर्टिकल लाइंस आर नथिंग, दीज आर एयर, दिस इज एयर. सो this L2CP is behaving like a curved wedge shape, right? Now when this air film, when this air film is illuminated normally by a monochromatic light, अब इसके ऊपर से अगर यहां से मोनोक्रोमेटिक लाइट आता है इस पॉइंट से, Now, this film of air, will behave like a wedge-shaped film. And when this air film is illuminated normally by a monochromatic light, a circular interference fringes will be observed. Why? See, इससे पहले क्या किया था, एक वेज शेप फिल्म लिया था. उस वेज शेप फिल्म में अगर यहाँ से लाइट आता है, now that light will travel through this and will get reflected back. ये भी रिफ्लेक्शन है. एक रिफ्लेक्शन ये आया था, जीरो रे था. फर्स्ट रे फ्रॉम द डायरेक्ट रिफ्लेक्शन, सेकंड रे आफ्टर reflection, it got again reflected back in the same medium. So the interference pattern between this 1 and 2 was giving you interference pattern because of the wedge shaped geometry. Similarly, in this case also, this air is behaving like a wedge shaped film. Air is behaving like a wedge shaped film, and the interference pattern because of this L2CP wedge shaped film, I will observe a interference pattern like this. And this interference pattern is called neutral rings. This interference pattern is called neutral rings, which is because of the air film engulfed between this plano-convex lens and a glass plate. If I see, just like the wedge-shaped film, if I draw like this, and this, now suppose a ray of light goes something like this, and I am calling this point as B point. And on this interface at point B, it will get reflection like this, right? Let's say this will be I. Again, this will be I. This ray get reflected as well as it will get refracted also, and it will bend away from the normal because it is moving from denser to rarer medium R. Now it will go into this. इसका ज्योमेट्री छोटा रह गया. Okay, so it will go like this, and it will transmit. It will refract from the glass medium. So 0, 1, and 2. So this zeroth ray at point B, it got reflected as well as refracted. The reflected part I am denoting as 1. The refracted part, this part, the ray BE, will again, of course, it will get refracted, but I am just considering the reflected one. So BE will get reflected in the direction, let's say EN. This is M, this is N. So this EN ray will get, again it will get reflected at this surface, but I am not considering that. I am just considering the refracted part this time. So En will give you second ray. So the interference pattern between this M and N, between this first and second ray, this will give you an interference pattern. This interference pattern will be based on the facts that from where this ray 1 and 2 is originating, at which point, let's say at point B, and how far this point B was from the point C. ये C point हमने consider किया था जहाँ पे touchdown होता है. At how far this point B is from C. Basically, it depends on the thickness of point B from point O. Let's call this point as not O, F. So the thickness of the air column just below the point B will give you whether it will be a constructive interference or it will be a destructive interference. Right. Now, the path difference between two rays, the path difference between these two rays, that is ray 1 and ray 2, क्या होगा पाथ डिफरेंस, किसी को आइडिया है? It will be equal to, the path difference will be equal to 2 mu t cos r. वही तो है ये जो इस वैश्य फिल्म में इस पॉइंट पे जो पाथ डिफरेंस था, इस पे जो पाथ डिफरेंस था, this part and this part was equal to 2 mu t cos r. So the ray 1 and ray 2 will have a path difference of 2 mu t cos r. Now since one of the rays is reflected from denser medium at point B, ये जो रिफ्लेक्शन है जो रे 1 है, रे 1 इज क्रिएटेड बिकॉज ऑफ द रिफ्लेक्शन at denser rarer interface. The point B represents the denser rarer interface, right? So there will be no path difference, no path or phase difference, no path or phase difference in ray 1 as it was reflected from denser rarer इंटरफेस एट बी. 1 में कोई एडिशनल पाथ डिफरेंस नहीं होगा बिकॉज ऑफ स्टोक्स लॉ, कोई पाथ डिफरेंस नहीं होगा बिकॉज इट हैज रिफ्लेक्टेड फ्रॉम पॉइंट बी which is denser rarer interface. But at point E, this ray 2 has suffered a reflection at rarer to denser interface. Right? This ray 2 has suffered a reflection at rarer denser interface at point E. Because ये तो सब एयर कॉलम था, ये तो एयर कॉलम था ना. सो ये एयर कॉलम था तो एयर से ग्लास, नीचे ग्लास प्लेट था, तो एयर से ग्लास प्लेट का इंटरफेस है एट पॉइंट ई. सो इफ इट गेट रिफ्लेक्टेड फ्रॉम पॉइंट ई, it will suffer a phase change of pi or a path change of lambda by 2. Right? So this geometrical path difference was 2 mu t cos r, but now because of Stokes law, there will be a additional path difference of lambda by 2 because of Stokes law, and the total path difference between these two rays, ray 1 and ray 2, will be equal to now 2 mu t cos r plus lambda by 2, or you can say minus lambda by 2, it doesn't matter. Right? So the total path difference between ray 1 and ray 2 is 2 mu t cos r plus lambda by 2. कुछ डिफरेंस नहीं है, एग्जैक्टली सेम चीज है जो वैश्य फिल्म में कराया था वो ही है दोबारा से. वैश्य फिल्म में भी यही रिजल्ट आया था और इसमें भी यही आया है. द ओनली डिफरेंस आई विल टेल यू लेटर इन न्यूटन रिंग्स एंड वैश्य फिल्म इज दैट, okay, first derive the condition for bright and dark fringes, then we will discuss what is the difference between the wedge shape and Newton rings. So this total path difference is 2 mu t cos r plus lambda by 2. This path difference, if this path difference is equal to L lambda, that is integral multiple of wavelength, then it will form a constructive interference and it will give you a bright fringe. Because of constructive interference, you will get a bright fringe if this condition is true. So this condition I can modify with 2 mu t cos r will be equal to 2n minus 1 by 2 lambda. So this will be the condition for bright fringe in case of Newton rings. Right now, but this condition, this cos r, I want to see in our system. Generally आपने जो एक्सपेरिमेंट परफॉर्म भी किया होगा लैब में, the rays which are coming on this section L2CP, the rays which are coming to this section L2CP are generally normal rays. Normal rays means perpendicular to this glass plate P. Perpendicular to this glass plate P. So I can modify my this expression for normal incidence. For normal incidence, I can say my I will be 0 and correspondingly my R will also be 0. For normal incidence on this system, for normal incidence of light on this system, my angle of incidence will be 0 and correspondingly angle of refraction will also be equal to 0. So this cos R is going to be, I can make this cos R as 1. So this 2 mu t we can be written as 2n minus 1 by 2 lambda. So this will be the condition of bright fringe in this case. Now I want to see how this thickness, this T, can I relate? This T is nothing. This T is the thickness of the air film at point below the point at which interference is happening. If I am considering interference at point B, then this T is length BF. This T is length BF. If let's say I consider the interference at point X, then the value of this T will be nothing. It will be the height of the air column just below point X. So the XY distance will be the thickness of air column because of which interference is happening. So this T is the thickness of the air column. This T is the thickness of the air column from where the interference is arising. Right? In this particular case, the thickness is BF. So the value of T will be equal to just plainly BF. अगर थोड़ा सा और आगे से मैं कंसीडर करता हूं तो my thickness, my value of T will change, and now my thickness of this air column will give me the conditions whether it will be a constructive interference or it will be a destructive interference. So the value of T, will change in this system. The value of the T will change continuously. Her point pe the value of T is changing, and because of this change in T, successively my interference condition of bright fringe and dark fringe will satisfy, and hence a complete dark and bright fringes will appear on the both side of this curvature of the lens. C point के दोनों साइड आपको सक्सेसिवली ब्राइट और डार्क फ्रिंज मिलेंगी as soon as this T, this thickness is so that it satisfies the condition for bright and dark fringes. जैसे ही thickness change होगा, condition change हो जाएगा. Maybe we will achieve condition for destructive interference, so there will be a dark fringe. थोड़ा सा thickness और आगे जाएंगे तो thickness बढ़ जाएगा, फिर दोबारा से दूसरे टाइप की कंडीशन सेटिस्फाई होने लग जाएगी, and there will be a bright fringe. So consecutively there will be a bright and dark fringes. But now the difference between this geometry is two-dimensional, but the system, the plano-convex lens as well as this glass plate was three-dimensional. So in this case, the fringes will be circular. The fringes will be circular, right? वेज शेप फिल्म में क्या था कि इस पॉइंट पे थिकनेस चेंज होता था तो आपको फ्रिंजेस मिलता था, but those are parallel fringes. पैरेलल लाइंस मिलता था फ्रिंजेस का, राइट. बट इन केस ऑफ न्यूटन रिंग्स, because of the geometry, this the fringes will be circular in nature, right. इसको देखते हैं एक बार कैसा है. Let's say, see, if you can see my screen, यहाँ से कैसे, okay, so you can see this interference pattern is actually the interference pattern created by the West-Shaped film. These are parallel lines, parallel uh, interference patterns. इट इज अ कंस्ट्रक्टिव इंटरफेरेंस. थोड़ी देर बाद फिर दूसरे कलर का कंस्ट्रक्टिव होगा, फिर तीसरे कलर का होगा, और एक पॉइंट आएगा जब बिल्कुल डार्क फ्रिंज आ जाएगा. बट in case of Newton ring setup, this type of interference pattern will be there. Concentric circles will be there, and these circles are nothing. These circles are interference fringes. At this point, at the bright point, it is satisfying the condition for constructive interference. At dark point, it is satisfying the condition for destructive interference. So the nature of the locus of the fringes in case of Newton rings will be circular in nature, while in case of thin films it will be parallel fringes, straight line fringes, right. So okay, फिर आएंगे इस पे. क्या हुआ? Okay, so but so this condition will actually give you an idea at which thicknesses constructive interference will happen. Now, this T, actually I want to replace this T with some different parameters, which are distance from the center and the radius of the curvature of the plano-convex lens. देखते हैं इसको कैसे करना है. This was our film. This was plano-convex lens. This was center point C, let's say. This was T. T is the thickness of plano-convex lens. This is R. R is the radius of curvature. R is the radius of curvature of plano-convex lens. Radius of curvature of plano-convex lens. P is the thickness of lens. A small r is nothing. It is the distance from the center of the system, which is C. Small r is nothing. It is the distance of the system from the center. Now, this distance is nothing. It will be r minus t. ये भी radius था, ये this total is also radius, this total is also a radius. So this t total radius r minus this thickness t will be capital R minus t. This distance will be R minus t. Points बना ही लेते हैं. O point है, A point है, B point है, C. So this OA is radius of curvature. OC will also be radius of curvature. ये फिगर जो है वो स्केल की नहीं है पूरा, but this OR is the radius of curvature. So OC has to be also be radius of curvature R. So this OB distance has to be capital R minus T. And this R is nothing; it is the distance from the center of the system. So in triangle OAB, R square will be equal to small r square plus r minus t square. So if I open this bracket, it will be r square plus capital R square plus small t square minus 2rt. So 2rt will be equal to r square plus t square. This t square I can neglect because the thickness of this is very very small. That's why this geometry मैंने ऐसा ही बनाया था, but t actually is very very small. The thickness of this glass plate will be very small. The curvature is very large, right? So if I neglect t, it will be 2rt will be equal to r square. So this r square is nothing; it will be capital 2r t. This r, if I say this r as d, this r is nothing, this is the locus. This r represents the position of fringe, from the center point C. Let's say a fringe is happening at this point A. At this point fringe is creating. Now the position of this fringe from point C is given by R. So this R is nothing. I can say this R is the radius of the fringe. Radius of the nth fringe. So this R I can replace with d square by 4. R is d by 2. So d square by 4 is equal to 2rt. So from this I can say 2t is coming to be d square by 4r. I am writing this 2t is equal to d square by 4r. दोबारा से देखते हैं t क्या है, थिकनेस है ग्लास का, मैक्सिमम थिकनेस है पॉइंट b एंड c के बीच में. d स्क्वायर क्या है, d स्क्वायर इज द डायमीटर ऑफ द फ्रिंज. जो सर्कुलर फ्रिंज बन रहा है उनका डायमीटर है d. 4r is nothing, 4r is r is radius of the curvature of the plano-convex lens. So this 2t is coming to be d square by 4r. So if I insert this 2t is equal to d square by 4r here, 2t was equal to 2n minus 1 by 2 lambda by mu. So if I insert this 2t value from there, it will be d square by 4r will be equal to 2n minus 1 by 2 lambda by mu. Right? Now, this I can write as d square is equal to 2n minus 1 by 2 lambda by mu into 4r. This d square is nothing. This is the diameter of the nth ring. This is diameter. This is the position. This is the position. This will give you this d square. This d will give you the position of nth bright fringe. If you start inserting values of n is equal to 0, 1, 2, 3, 4 here, it will start, this relation will start giving you the diameter of first bright, second bright, third bright fringe. Right? So this d is nothing. This is the diameter which you will obtain on the interference spectrum of the bright fringes, in case of bright fringes. Right? Now, this relation is very important. d square is equal to 2n minus 1 by 2 lambda by mu into 4r. This gives you the diameter. This will give you exactly the location at which particular bright fringe will be there. Suppose if you want to find from the center, what will be the diameter, what will be the position of fifth bright fringe. So you just have to insert n is equal to 5. So it will be 5 into 2, 10. 9 by 2 into lambda, the wavelength which you are using in this setup. Mu, refractive index. Refractive index of what? Refractive index of air. Refractive index of air film, because in this case, air is the film which is creating the interference pattern. So do not confuse this mu with the glass media, with the glass refractive index. It is not the refractive index of glass. This 2 mu t cos r was the phase difference, was the path difference created by the film. And in this case, the film was air column. In this case, the film was air column. So you have to remember this. This 2 mu t cos r is the path difference created between this ray 1 and 2 because of the air film. And now this mu is of the air, not because of not of the glass medium of which this plano convex lens and this glass plate is made of. इसका नहीं है, रिफ्रैक्टिव इंडेक्स ग्लास का नहीं है, रिफ्रैक्टिव इंडेक्स है एयर फिल्म का, राइट. सो इन मोस्ट ऑफ द केसेस दिस म्यू विल बी इक्वल टू 1. In most of the cases, in simple cases in which this air film is creating the interference pattern, this mu will be equal to 1. So this d will give you the d will give you the distance from the center of the nth ring, कि अगर भाई इसमें थर्ड रिंग कहाँ आएगी, थर्ड ब्राइट फ्रिंज कहाँ आएगी, फोर्थ ब्राइट फ्रिंज कहाँ आएगी. This d can give you that. Now this condition, the first expression was considered that the path difference is equal to n lambda, then this will be the condition for constructive interference, that is for bright fringe. Now the same path difference 2 mu t cos r plus lambda by 2, if this path difference is equal to odd integral of lambda by 2, then it will be a condition for destructive interference and it will give you a dark fringe. It will give you a dark fringe. So the condition for dark fringe will be simple: 2 mu t cos r n lambda, right. ये वहां जाके प्लस प्लस होके n lambda रह जाएगा. cos r को again I can write 1. Cos r is equal to 1 as normal incidence is there. Normal incidence is there. Normal incidence का मतलब है परपेंडिकुलर फॉल कर रहा है लाइट ऊपर से सिस्टम के ऊपर. परपेंडिकुलर फॉल करता है तो नॉर्मल इंसिडेंस है, 90 का एंगल पे इंसिडेंस हो रहा है. So r will also be 90 and cos 90 will be cos r will be 0, so it will be 1. So 2 mu t is equal to n lambda. In case of dark fringe, 2 mu t will be equal to n lambda. So 2t will be equal to n lambda by mu. Again this mu is of air. So 2t I can write, this 2t I can write as d square by 4r. D square by 4r is equal to n lambda by mu. So this d I can also write as dn. Dn square by 4r is equal to n lambda by mu. Dn is nothing. Dn is the diameter of the nth ring, where n is the parameter which is changing. Like n is equal to 0. For n is equal to 0, you can see the diameter of the zeroth ring will be 0. So in this case, I can say the central fringe will be dark fringe. In this case, I can say if I insert n is equal to 0, my first fringe, my central fringe will be a dark one in this case. वो यहां से भी पता चल रहा था सिंपल वाली कंडीशन से भी. This 2 mu t cos r plus lambda by 2, that was the total path difference between ray 1 and ray 2. If t is going to be 0, at point C, of course the thickness of air column will be 0. At point C, Of course, the thickness of air column will be 0. So this 2 mu t cos r, this t is going to be 0, and the only path difference will become lambda by 2. And if the path difference between two rays is lambda by 2, then there will be a destructive interference and a dark fringe will form. So in case of Newton rings, conceptual question आता है एग्जाम में, पूछा जाता है कि explain why central fringe in Newton ring setup, central fringe is dark. You have to explain that at point C, thickness is equal to 0 and the total path difference is 2 mu t cos r plus lambda by 2. If t is 0, then the total path difference will reduce to lambda by 2 only. And if in between two rays path difference is lambda by 2, then there will be a destructive interference and hence a dark fringe will be there. So in Newton ring setup, the central fringe will be a dark one. Right? Now, another interesting thing is I have just arrived at a relation. This dn square by 4r is equal to n lambda by mu. This dn square by 4r is equal to n lambda by mu. I will write this as here. Dn square 4r and n lambda by mu. N lambda by mu. So this dn will be nothing. This is diameter of nth ring. This will be 2 root of n को भी मैं n को तो अंदर ही रखना है, तो it will be 2 मैंने बाहर निकाल लिया, उसका स्क्वायर रूट हटाया, तो it will be n r lambda by mu. Right. So I want to show you something from this relation. dn square by 4r is equal to n lambda by mu. dn को मैंने निकाल लिया in terms of other parameters. Now if I start inserting the values of n is equal to 1, 2, 3, 4, then what I am getting is 2 root of r lambda by mu. n को 1 रखा है. Diameter of second ring will be 2 dot root 2 dot root r lambda by mu. D3, diameter of third ring will be 2 root 3 dot root r lambda by mu. Similarly, diameter of fourth will be 2 dot root 4 dot root r lambda by mu. This shows that these D1, D2, D3, D4 are the diameters of the first, second, third, fourth bright dark fringes, right? If I try to find the distance between D2 and D1, that is the difference between diameter of second ray and first ray, it will be equal to twice of root r lambda by mu root 2 minus 1, right? यही होगा. This will be equal to, this is coming to be 0.414. वो 1.414 होता है तो minus 1 करके तो 0.414 into this parameter 2 r lambda by mu, right? 0.414. If I want to find the difference between third and second ring, it will be 2 root r lambda by mu, the same parameter, into root 3 minus root 2. रूट 3 माइनस रूट 2, राइट? वो d3 में से d2 डिक्रीज किया है, so it will be 1.732, it will be 1.414, so it is coming to be 0.318 into same factor 2 root r lambda by mu, right? Again, if I want to find d4 and d3 difference, the diameter difference of fourth ring and third ring, it is coming to be 2 root r lambda by mu, and it is coming to be root 4 minus root 3, and it will come to 0.268 into 2 root r lambda by mu. Now you can see that as we are going to higher order interference, this difference between these dark fringes d2 d1 d3 d2 and d4 d3, the difference between these dark fringes is decreasing. The difference between these dark fringes is decreasing. That means the final resultant pattern of Newton rings will be something like this: a dark central dark fringe, first dark fringe, second dark fringe, थर्ड और भी कम हो जाएगी, इसके पास आ जाएगी, फोर्थ और इसके पास आ जाएगी. So as you are going to higher order diffraction, as you are going to higher order diffraction, higher order interference, higher order uh, values of n, the distance between these diameters is decreasing. जिन बच्चों ने ये एक्सपेरिमेंट किया हुआ है लैब में, दे विल फील, उनको ये समझ में आ रहा होगा कि जो इंटरफेरेंस पैटर्न इन केस ऑफ दिस टाइप ऑफ सिस्टम, इट इज एक्चुअली कन्वर्जिंग, आई कैन से, राइट. सो यहां से अगर देखेंगे, देखिए इसमें देखिए, पहली डार्क फ्रिंज है, फिर फर्स्ट ये जीरोथ डार्क फ्रिंज है, दिस वन इज जीरोथ डार्क फ्रिंज, दिस वन इज फर्स्ट, दिस वन इज सेकंड, दिस वन इज थर्ड, फिर फोर्थ और पास आ गई उसके, फिफ्थ और पास आ गई, सिक्स्थ और पास आ गई, सेवंथ और पास आ गई. सो if you start increasing the value of n, if you start increasing the value of n, then the consecutive difference between the fringes will be decrease, will decrease, right. यहाँ से क्यों चला जाता है, जैसे ही स्क्रीन पे जाता हूँ यहाँ से चला जाता है. ओके, सो ये भी पूछा जाता है, ये आपको, यू हैव टू विद दिस रिलेशन, dn square is equal to 4 r n lambda by mu, you have to insert the values of n, you have to find the diameters of nth rings, and then you show the differences, and then you will show the thickness between these two, between these dark fringes will start going decreasing as n increases. So the dark ring as well as bright rings, of course, with the same case, with the same case will happen with the bright rings also. So the dark rings as well as bright rings gradually becomes narrower as their radii increases, right. इसके ऊपर न्यूमेरिकल्स आते हैं, कुछ करेंगे आज, कुछ आपको खुद करने हैं. सिमिलर सेटअप है न्यूटन रिंग्स बाय ट्रांसमिटेड लाइट, न्यूटन रिंग्स बाय ट्रांसमिटेड लाइट. तो मान लीजिए ये आपका सेटअप था. इन दिस केस आई विल सी हाउ द इंटरफेरेंस पैटर्न विल लुक लाइक इफ आई वांट टू सी फ्रॉम ट्रांसमिटेड सिस्टम. यहां से लाइट आया, ये जो भी जिस तरफ भी बेंड होना है आप देख लीजिए इसको, ये आई है, ये आर है, इट विल बेंड टुवर्ड्स द नॉर्मल. ये यहाँ से बाहर जाएगा, इट विल बेंड अवे फ्रॉम द नॉर्मल. इसके बाद यहाँ से फिर वापस ग्लास में आया है, एयर से इस ग्लास में आया है, इस ग्लास से आने के बाद लेट्स से इट इज गोइंग समथिंग लाइक दिस. और द फैक्टर्स जितना भी रिफ्लेक्शन रिफ्लेक्शन करना है देख लीजिए. ये सी पॉइंट है, लेट्स कंसीडर. ए पॉइंट से शुरू हुआ था, बी पॉइंट पे जो ग्लास प्लेट है वहां से रिफ्रेक्ट हुआ, सी की तरफ आया. इस बी पॉइंट से, इस बी पॉइंट से रिफ्लेक्ट भी होगा, रिफ्लेक्ट होके वापस ग्लास प्लेट पे जाएगा. मैं ये हमेशा छोटा क्यों बना देता. इस बी पॉइंट से वापस रिफ्लेक्ट होगा, मीडियम में जाएगा, मीडियम में जाके वापस इस पॉइंट से, लेट्स से एट पॉइंट डी, इट विल अगेन गेट रिफ्लेक्टेड, एंड फ्रॉम पॉइंट सी, not from point C, let's say from point E, it will go the other way, this way. So BC and EF, BC and EF are nothing. These are the transmitted wave front. These are the transmitted wave front from a single ray O. O, zero ray, first ray, second ray. So this first ray and second ray are actually the waves, the rays created from zeroth ray by the method of division of amplitude. Transmitted system है. So transmitted system में नीचे की तरफ देखा है हमने. Now again the path difference between B.Sc and Fe. The path difference between B.Sc and Fe will be equal to, again it will depend on the thickness of this BD. Thickness of BD will define the path difference between BC and EF, and whatever the thickness of BD at that point, it will be 2 mu T cos R. The thickness of this particular air column will define the path difference between BC and EF, and that will be equal to 2 mu T cos R, where T is the thickness of air column, mu is the refractive index of air. इस एरिया में जितना भी एयर है उस सबका थिकनेस है ये, इसमें जो एयर है, this is the air column. Because of this air column, interference is happening. Now स्टोक्स लॉ देखते हैं. BC जो पॉइंट है, at point BC there will be no phase difference. BC रे के लिए no phase difference, because ये कहीं पर भी जो A से बाहर निकला है, A से जो बाहर निकला है ट्रांसमिशन हुआ है, मतलब रिफ्रैक्शन हुआ है. A से B के बाद जब C की तरफ आया है तो भी रिफ्रैक्शन हुआ है. B से C की तरफ जब आया है लोअर सरफेस से तो भी रिफ्रैक्शन हुआ है. So there is no reflection in ray 1 directly from O, from zeroth ray, directly from O ray. It is directly coming with the help of refractions. Reflection कहीं नहीं हुआ है, refraction हुआ है हमेशा. So there will be of course no phase difference because of the Stokes law in ray 1, that is in ray BC. BC पे कुछ नहीं होगा. EF में देखते हैं. EF में देखेंगे तो at point B reflection was from rarer to denser medium. So yes, a path difference of lambda by 2 will be introduced. At point D, again there will be a reflection from rare denser surface. D point पे भी रिफ्लेक्शन हुआ है, B point पे भी रिफ्लेक्शन हुआ है, और दोनों ही रिफ्लेक्शंस रेयर डेंसर इंटरफेस पे हुए हैं. So there will be 2 times into the path difference, 2 times of lambda by 2 path difference between this ray EF. So EF में जो path difference, total path difference create होगा, that will be lambda by 2 plus lambda by 2. This lambda by 2 is because of point B, this lambda by 2 is because of the point D. So because it is suffering 2 reflections from rare denser interface, the total path difference will be equal to lambda. Lambda by 2 plus lambda by 2 is lambda. So as you know that if I introduce a total path difference, if I introduce a path difference of lambda in any wave, it will remain same. It will remain same. Lambda path difference होने से कुछ change नहीं होता. It will behave same. So the overall path difference between ray 1 and ray 2, that is BC and EF, it will be equal to 2 mu T cos R. As simple as that. 2 mu T cos R. Right. फिर वही बना लेते हैं कंस्ट्रक्टिव इंटरफेरेंस के लिए, यानी कि ब्राइट फ्रिंज के लिए. The total path difference, that is 2 mu T cos R, is equal to n lambda. ये कंडीशन हो गई आपकी ब्राइट फ्रिंज के लिए. इस पे भी देखेंगे, नॉर्मल इंसिडेंस मानते हैं, cos R को 1 मान लेते हैं. It will be 2t mu is equal to n lambda. 2t को वापस हम रख सकते हैं dn square by 4r. So dn square by 4r will be equal to n lambda by mu for bright fringe. So this dn square is nothing, it is giving you the diameter of bright fringe in case of transmitted system. In case of transmitted system. this dn is giving you the diameter of bright fringe in case of transmitted system. Similarly, in destructive interference to happen, that is for dark fringe, the condition will be this path difference 2 mu t cos r will be equal to, should be equal to 2n minus or plus, in fact 2n minus 1 by 2 lambda. The path difference should be equal to 2n minus 1 by 2 into lambda. So this again, this I can write as 2t dot mu is equal to 2n minus 1 by 2 lambda. This 2t I can replace with dn square by 4r. So this dn square will be equal to 2n minus 1 by 2 lambda by mu into 4r. Right? dn square will be equal to 2n minus 1 by 2 lambda by mu into 4r. So these will be the locus for the dark fringes. This will be the locus for the bright fringes. You can just start inserting the values of n and you will get the diameters of bright fringes and dark fringes. In this case, can you tell me what will be the nature of central fringe?
Bright.
The central fringe will be bright because in this case, if I insert t is equal to 0, then the total path difference between these ray 1 and ray 2 is going to be 0. So if total path difference is 0, it always constructive interference will happen and hence bright fringe will be there. Right? So I just want to show you again. ये फिर दोबारा से हटेगा, मेरे को फिर लगाएंगे, बट जाएंगे हम उस पे. So on this screen, I can see you have to tell me this Newton rings fringes are actually the resultant of reflected system. जो अभी तक हम देख रहे थे, these are the resultant of reflected system. But if I want to see my Newton rings down from the setup, transmitted side से मैं देखता हूँ, it will be something like this. Right? It will be something like this. In this, you can see the central fringes bright and the first dark fringe आएगी, फिर first bright आएगी, फिर dark आएगी, फिर bright आएगी. And you can see even in this case, you can see if n is increasing, the spacing between the concentric dark and bright fringes is decreasing. जो अभी हमने प्रूव भी किया था वैल्यूज डाल के, जैसे जैसे n का वैल्यूज बढ़ता है, the spacing between the fringes will decrease. But from this figure, you can see directly that this particular case is derived. The interference pattern is obtained by the case of transmitted light. By transmitted light, ऐसा आना चाहिए और रिफ्लेक्टेड में ऐसा आना चाहिए. रिफ्लेक्टेड में नीचे जो आ रखे दो छोटे छोटे ये आना चाहिए और ट्रांसमिटेड में वैसा आना चाहिए. ठीक है, ये है. ओके, तो अब हम वापस उस पर राइट. और भी है इससे कुछ कुछ क्या है. हाँ, ये चीजें है, ये भी इम्पोर्टेंट है, करते हैं. अच्छा, इसमें वापस ओके. सो फ्रॉम ऑल दिस थिंग एक न्यूमेरिकल्स के लिए कुछ बनता है इस पे.